one of our latest works we have been doing in TFS that landed now in release 6. It's about automation. It's one of the new components that landed recently in TFS. And the idea is basically to state a bit how we manage to close the loops in a ZSM-like fashion in TFS by leveraging some state that we can get from underlying telemetry modules. This is able to feed now new components in TFS, like intelligent components, which can do smart analytics and stuff like that. And then with a new automation component that we provide, and also a neat way of creating different types of automation loops with this component, because it's a plugin-based one, we are able to get back to the network and close the loop with some sort of service reconfiguration actions. This is vital for 6G, and I think it's a good starting activity in TFS to see more things about automation in the future. Before going into the form of automation today, I would like to step back a bit and see how was this implemented in release 5 initially. There was an automation component before. It was developed in a quick and dirty fashion, let's say, previously in TFS, and it was using an architecture which is shown in this figure. Basically, there was a gRPC API which was connecting this component with the rest of the TFS ecosystem. And the idea here is that the user previously in the previous automation component had to create some KPIs inside the automation component. And prior to starting the collection of data for these KPIs, then there was a need to start a collector to collect those KPIs. This was feeding an analyzer to process the collected KPIs. And then there was a policy component which was going over the outputs of the analyzer, trying to close the loop with the service. This was the initial architecture of the automation component. And this was a bit rigid, so to say. We didn't have much flexibility in the way to introduce new KPIs, new collectors for different types of underlying networks, such as optical, IP, whatever. So we decided that this was not going very far, and we had to create a mechanism which would allow automation to have plugin components, so as it would be more natural for the developer to define his own scenario, his own KPIs, his own collection method, and his own policies. So this was the intuition behind leading us to the new developments for automation and the need to revisit this component in release 6. And this is now how we attempted to re-architect automation in TFS. So the architecture now is a bit different. We have an abstract API, which allows to introduce automation service handlers, basically. And there is a placeholder inside the Git repository of the automation component to create those handlers on demand. What we did as a proof of concept was to implement one ZSM service handler for P4 INT, in-band telemetry, just to showcase how this can be done, basically. So this INT automation handler was inheriting the abstract methods from the abstract handler and implementing those for a specific scenario, which was about a P4 topology that was able to collect metrics via in-band network telemetry. Then, underneath the automation component, for every automation loop to be able to close, we need to integrate with some existing services. And we need to also provide existing KPIs to the analyzer for further processing and also define policies, as it was done pretty much previously. But now there is better flexibility in the new architecture because we don't define those KPIs inside the automation, let's say, logic. We just inherit those or declare those from existing services. And also we bind with existing services underneath to close the loop. Let's see what are the prerequisites for starting this automation loop. Before we attempt to automate anything, we must first have a service in the data plane. And also for this service, we need KPIs. So without a service to automate and without monitoring data from this service, we cannot really automate anything. This is really a prerequisite for automation in TFS. How can we do that? In our scenario, at least, when we implemented this in-band network telemetry case, we had first to provision this P4 INT telemetry service. This was done via the service API of TeraFlow. It's one of the regular TFS services in the service repository. This is done via a service handler for P4 INT, which now, when it starts and when it provisions INT rules to the P4 switches, it is also responsible for starting an INT collector towards the telemetry component of TFS. This is also implemented using plugin-based logics. So we have a P4 INT specific collector in telemetry, which is now able to collect metrics from the switches. So when the service handler instructs the switches to send INT data to the collector, then we have a case here. We have a running network of P4 devices, a service which configures those devices with INT rules to send INT data to a collector, and also a collector listening for those metrics. So at this point, the network is ready to monitor, let's say. What goes next? Next, we need to provision an actual connectivity service in the network because so far the switches are only able to report INT data, but there's no traffic going on. So we also use again the service API and a different service handler, which is now the layer 2 service handler in P4, to instruct the switches to perform layer 2 forwarding, let's say between the sender and the receiver in this underlying topology. When we have those rules in the data plane, there is connectivity established, and there can be packets flowing from sender to receiver and back. When this is happening, now we animate here while a packet goes towards the receiver. There is also an INT packet generating, going to the collector and notifying the collector about telemetry data for this specific service. So when we have activity in the network with packets going here and there, we also have activity for telemetry reported to the INT collector. So at this point, this collector is also able to store the INT data into a Kafka topic. This is the new telemetry system of TFS. And at this point, the telemetry becomes available in TFS and becomes, let's say, usable by other TFS components. So far, we have a telemetry service in place. It's at the service level of TFS, the P4 INT service handler. We have a collector being invoked to collect this data, and we also have a connectivity service, which is the target service for us in this scenario. These are the three prerequisites. Now we are able to automate something because we have a running service and we have data for this service available. Let's see what we can automate now. In this animation, you see here on the right-hand side an example JSON file to trigger a new ZSM loop, a new automation loop via the automation components. And at the top part, you see that we have the two prerequisites here already in place. A target service ID, which is this one, and this corresponds to the layer 2 service that we had started previously. And the telemetry service ID, which is this one, and it corresponds to the P4 INT service that was also provisioned previously and also resulted in the deployment of the INT collector. So these are the two important, let's say, prerequisites for starting a new automation loop. And now let's see what's next. Next, we have another part of the JSON body, which is split in two parts. The first part is a custom analyzer. This analyzer defines, first of all, an analysis method over some specific KPI that was produced by the INT collector previously. Here we can also parameterize this analyzer on demand, and also define some thresholds to generate alarms when something goes beyond or below some specific value. We also define the list of input KPIs where this analyzer operates on, and also an output KPI, which will be the outcome of the analysis. In our case, we have three, let's say, input KPIs and one output KPI, but here the developer has the flexibility to create new analyzer methods on demand. So this analyzer gets those three KPIs as inputs, processes the data, and based on those thresholds, creates an output KPI and also potential alarms. Those alarms now are shipped to the policy component, which goes next. And here we have the ability to define a policy. The important parts of this JSON are the target service ID that we would like to configure. This is the same service ID that we have here, if you notice. It's the layer 2 P4 service in our scenario. And a set of actions to enforce when the alarm is triggered by the analyzer. In our case, the action is to call the service API and update the service with some configuration. So to see this in action in the previous animation, we stopped in step 8 when we had all services in place and also the telemetry collector in place. Now, when the analyzer is started by the automation component, it reads input KPIs from the Kafka bus and also produces new output KPIs based on what we asked it to do. It also registers an alarm on a specific output KPI so that it would be able to get notifications from Kafka when this alarm is triggered. And the same happens for policy. It also subscribes for alarms here with a service ID to the same Kafka bus. So when an alarm is triggered, it is sent back to policy as a notification, and policy is executed to enforce the specific policy that we had asked to perform. This, in our case, results in a service API call, which goes through the service handler and executes some specific adaptation in the connectivity service that we had established previously. So this is exactly how we attempted to close the loop with the synergy of 5 components in total: several services, connectivity and telemetry, the telemetry collector, the analytics, the policy, and the automation acting as an umbrella here. So this is at a high level how automation works. Now, how it was architected, let's say, to become plugin based. This is a set of methods that this abstract ZSM handler defines. These are abstract because here, as you see, they're not implemented. And because this abstract handler is inherited by any other handler that we would like to build, the new, let's say, childs of this class have to implement these methods here themselves. Why this is neat? It's neat because you can have multiple automation handlers for different types of scenarios here, depending on which types of services you want to automate, what kind of policies you would like to have, or telemetry data, and so on and so forth. So it gives the freedom to the programmer to define his own loops. How this works underneath. We need to define some target service type values here and also some telemetry service type values to allow this handler to have mappings. So in other words, to know, depending on those values, which handler should be invoked every time the automation component is called. In our scenario, we have for a target service, we have a service layer 2 network management type. And for telemetry, we have a service type INT. So the combination of the two actually results in a call in our INT ZSM handler. Of course, here, if developers want to extend this whole concept and create new automation handlers, they can define their own target service values and telemetry values here and produce different combinations that correspond to different automation loops. How the in-band network telemetry ZSM plugin now looks in our example, as you see, it's a class which implements this abstract ZSM handler. And here we have a short snippet of code which shows the ZSM create function. There are three parts again to highlight here. The first part has to do with the connection of the ZSM handler with some input services. Specifically here we have a target service, which is the layer 2 P4 service, and a telemetry service, which is the INT P4 service. We start an analyzer, which takes the data from that JSON file that I showed you earlier. And then the last part is the creation of the policy and the invocation of the corresponding policy add service function through gRPC. To invoke the policy component. So it's really simple to create a new ZSM plugin. The code is not too much, simply because the work is done mainly in the JSON to define the elements of these objects here, and also in the background through the plugin mechanism of the automation component. So the way we have re-architected now the automation component suggests a new approach in TFS, which, at least in our case, we feel it's convenient to follow, at least for the P4 aspects that UBITECH is working on. And this is telemetry as a service. What it means? This means that we should not be, let's say, creating telemetry collection services without them being real services in TFS. What we had done before in release 5 was starting those collectors as part of the automation. So there was no real service doing telemetry collection. There was an invocation to the telemetry collector to start via the automation component. And the developer needed to know the KPIs in advance and start the collector from within the automation. But here a natural question would be, what if somebody needs telemetry without automation? What if we need to just create a telemetry collection process without having an automation loop on top, just to see what's happening in the network? This is why we believe that having telemetry as a service is useful, because in that case, if the developer needs to create or provision a new telemetry service in a specific network, it just calls the service API and starts the collection process as a service. This makes telemetry individual from any other component like automation or others. And correspondingly, the telemetry service can live as long as the actual service to be monitored. So here we showcase how we did the telemetry as a service in the P4 INT service handler. This service handler, as I said previously, is sending some INT rules in the P4 switches to start the in-band network telemetry collection, right? But at the same time, it just implements one additional method, which is start collector, that is able to provision the collector itself as well through the service layer. This is pretty simple. We just define an abstract INT KPI initially here through the KPI descriptor object. We set this KPI descriptor through the KPI manager component, and then we create a collector object. We configure it with this KPI and some data that is relevant for INT, like which interface we would like to use for collection, on which port, for which service, and so on. And then we issue a service request to the telemetry frontend to start this collector. So this triggers a communication between service layer and telemetry layers, and the collector gets started from within the service. Especially in the INT case, our collector was a bit different from the existing collectors in TFS because this collector resides inside TFS, let's say. It's, let's say, listening in the same VM where TFS is deployed. And because the switches might be remote to the collector, to the TFS controller, we need to expose this collector as a load balancer service. So we had to engineer further the Kubernetes deployment of TFS to deploy this load balancer component for telemetry, which binds on a specific IP, which in this case is the IP of the TFS VM itself, and a specific port, which in this case is 12345. And this allows configuring MetalLB to listen on a specific network interface on the host machine of TFS, expecting packets, INT packets from the switches. Well, some words about who are behind the work. Myself, my colleague Kostas, who is not with us anymore, and Nikos Psaromanolakis are the contributors in this work. This work was done in the context mostly of flex scale and across projects. And the first time this work appeared, let's say, as a complete POC was last May at CTDC when we presented zero-touch onboarding and adaptation of P4 data planes leveraging INT. I have here some information about this presentation. And the way forward for release 7 is basically to open up this discussion about the new structure of automation to the TFS community and possibly get feedback from the community with regards to basically the opinion of the community about this new design and potential things that we can further improve. I guess this can happen through the TFS calls, tech calls in the future. Yeah, that's all from my side. I don't know if you have any questions.
Thank you very much, George, for the very nice presentation.